On April 19, 2026, 12,000 runners gathered for the Beijing Half-Marathon. Among the crowd, over 100 Chinese-made humanoid robots lined up at the starting line, waiting for the pistol to fire. Historically, long-distance endurance has been humanity's primary biological advantage. We are persistence hunters, capable of outrunning almost any other animal over 21 kilometers. That advantage met its match in 50 minutes and 26 seconds. That is the time it took Lightning, a robot developed by the smartphone maker Honor, to complete the course. This chart compares the human half-marathon world record against Lightning's finish. The machine cleared the course 7 minutes faster. Maintaining this pace for an hour proves engineers solved the twin hurdles of battery capacity and bipedal balance. Machines are no longer confined to lifting heavy weights in factories. They can now out-persist us in the real world. Near the finish line, Lightning lost its balance and crashed into a metal railing, requiring a human to help it up. That crash demonstrated a breakthrough in graceful degradation. Modern hardware is designed to take a physical hit and maintain the integrity of its internal systems. China's T-800 humanoid takes this further. Fight videos show the machine losing its head entirely while continuing to swing and move its limbs. This durability is part of a global surge in mass-produced hardware. Showrooms like Unitree's are filled with agile, bipedal platforms accessible to industrial buyers. Western competitors are matching this shift. Boston Dynamics recently unveiled this production-ready, fully electric version of their Atlas humanoid. By replacing older hydraulic systems with electric motors, engineers have created robots that are lighter, carry higher torque, and cost significantly less to manufacture. Hardware is no longer the primary bottleneck in robotics. We have created resilient, mass-producible skeletons that are simply waiting for the right software. That software is a framework known as physical AI, the intelligence system that acts as the robot's brain and nervous system. The capital behind these brains is immense. Neurorobotics recently closed a $1.4 billion funding round to fund the production of these next-generation systems. To maintain this breakneck pace, tech firms adopted 996 cultures, working 12-hour days, 6 days a week, to compress years into months. This diagram shows the robot functioning as a software endpoint. The machine transmits field data to a cloud server, which computes a more efficient movement path, sending an over-the-air update to smooth the robot's gait while actively deployed. Because of physical AI, a robot's capabilities are not fixed, not to factory. Every hour spent running provides the data for a software update that refines its movements for the next day. The half-marathon was a public stress test for the real world. The ultimate goal for these machines is navigating chaotic, unstructured environments like construction sites. The dynamic balance and battery endurance proven in the race are the same traits required for heavy labor in logistics and search and rescue. Our world is built for the human form, full of stairs, narrow hallways, and uneven ground. Mastering the bipedal gait was the final requirement for a robot to work in our spaces. The 2026 marathon showed these machines operating on public streets, performing under the same variables and unpredictability as the humans they were racing. The Beijing Half-Marathon proved that a machine can now out-persist a human athlete over 21 kilometers. Our biological endurance now has a mechanical rival that is simply more efficient.